Okay, so what we're going to talk about today is more word problems. The difference between, this is objective 96, difference between what we did last week and what we're doing this week is this, on this objective you're going to be given a situation and you're not going to make the y equals mx plus b. If you remember last week when we draw the little L, and we talked about what the graph should look like, that's all we're going to have to do. You're going to get 4 graphs and you're going to say which one would be the right line, the right y equals mx plus b for the situation. Now, 2 things to remember. We talked last week about any problem that involves money. Remember, we're going to make an x and y axis. But if the problem involves money, what axis did we put that on? The 50-50 here. What do you think? The y-axis. The up and down axis. The y-axis. So when a problem involves money, what axis do we put it on? Not everybody at once. The y-axis. That is the most depressed y-axis I've ever heard. So sad. If a problem involves time, so likewise, all right, if it involves money, you're going to put it like, if this was the graph, if this was money, money would be this axis. Another key, not every problem involves money. I'm just saying if it does. And the other thing is if it involves time, dates, minutes, seconds, years, you're going to put that on what axis?
X.
There we go. X. Everybody's more excited about X. Y was depressing. X was like only half depressing. Okay, now since we talked about money and we talked about time, I'm going to give you an example of a problem that has absolutely neither of those 2 things. Maybe one on the back side does. I don't know. I don't know what I was thinking when I made it. But let me remind you about money and time, and then let's talk about a problem that has nothing to do with that.
Okay.
All right, so here's the deal. A family's going to drive. We're going to drive on vacation or drive across the country. Yeah, on both of those. We're driving across the country on vacation. We're going to start with 16 gallons of gas and use about 1 gallon every 20 miles. One of these graphs relates the distance the family drives to the amount of remaining fuel. Which graph is it? As you can see, all of these have remaining fuel on the y-axis, so it's not even like a mystery. I would normally go, hey, where does fuel go, the x, y axis? The fuel in your gas tank is going to go down. It is the y-axis. So then the x-axis is how many miles have you driven? So the big question is, let's look at the first graph and think about this. How many gallons were in the tank when we started?
16.
It was 16 gallons. So wouldn't you imagine if I have traveled 0 miles, that shouldn't there be 16 gallons in the tank? Hopefully. Now, what does this show? This shows if you've gone 0 miles, that you have 0 gallons in the tank, and it doesn't work like that. And then somehow, the more you drive, gas gets like magically put into your car is what this is showing. So it can't be this one.
They got a gas can with them.
But how would they make it go if they had no gas to start? It's like they push it down a hill, and then they've got some kid out the window putting gas in it.
Yeah.
That is very weird. That is a weird picture.
I believe Patrick's
Okay, so if you've gone 0 miles, how many gallons are supposed to be in that tank?
16.
No, there's not 0 gallons of gas in the car. There's, Patrick?
16.
16. So what you want is you want the one that says, if I haven't gone anywhere, I need 16 gallons. So you need to have one that starts up here. What answers start up at 16? C and D. C and D. C and D. That means, let's answer that question down bottom. All right, since we start with 16 gallons, 16 should be our what? What are these dots I placed? What are those called?
It should be our zebra.
Y,
Axis.
like our y-intercept. Our y, that should be on the y-axis. It's our y-intercept. It's the dot on the y-axis. So since we start with 16 gallons, 16 is our y-intercept, as in answers, and you already told me this, B and D. As in answers B and D. Now here's the deal. If our tank, remember there's 16 gallons in your tank. Every 20 miles, so this is 16, every 20 miles, now it's 15. Then another 20 miles, it's 14. So if our tank drops 1 gallon for every 20 miles, then we should be at 15. If we were at 16, after 20 miles, we should be at 15 gallons when we had 20 miles. So let's look at this B over here and just see. I'm pretty sure this is actually the right one, so I should have looked at the other one first. But okay, Notice one thing. Notice the tick marks on the left. We're going 4, 8, 12, 16. So what are these other tick marks? If this is 4, what's this?
2.
2. So this is 2, 4, 6, 8, 10, 12, 14, 16. I'm trying to find where would 15 be. So if this is 14 right here, that's 14, then halfway between, that's 14. Halfway is 15. So what I'm looking is, after I go 20 miles, how many gallons are in my tank? Is it 15?
Yes.
That's it. So after 20 miles, I should be down from 16 to 15. After 40 miles, I should be down from 15 to 14. So what you're looking at is B is going to be the right answer. Let's just really quickly look at why D is not. And this one's tricky. This is why you have to be careful, because after 20 miles, it looks like it went down 1 tick mark. But 1 tick mark is actually going from 16 to 14, because 16, 14, 12. So after 20 miles, it's not down 1 tick mark. It's got to be down from 16 to 15. And this would be at 14. So be careful of how the y-axis is labeled. All right, we got 2 more situations, so let's look at what we got on the back side. The graphs are the same. And these are actually nice graphs. You see some of your older objectives have kind of crappy graphs with dots. So these are like the newer objectives. They made them look a little cleaner for you. All right, here's the situation. Lisa's training for a 100-meter wheelchair race. Bless you.
Thank you.
Her friend stands at the finish line. Circle finish line really quick, because this problem will change from finish line to starting line, as you're going to see on the next problem. All right, Lisa's training for a 100-meter wheelchair race. Her friend stands at the finish line and times her with a stopwatch. It takes Lisa 23 seconds to complete a practice race. Which graph models the distance between the 2 friends for the first 10 seconds? Let's read it over here on the left. It says the x-axis only goes to 10 seconds. So keep that in mind. Does this problem involve money? When we talk about money and time, does it involve money?
No.
No. But does it involve time?
Yes.
Yes. And on the previous page, we said if it involved time, time is what? Axis.
Y.
Ooh.
I mean X.
Time goes on the x-axis.
Something.
So yeah, this involves time. So what we're looking at is, if you're racing somebody, time is the x-axis, and this is time in seconds. 1 second, 2 seconds, 3 seconds. The race is 100 meters. Now, if our friend is at the finish line, like right before we start, if the race is 100 meters, and she's at the start, and her friend's at the finish, how far apart are these two when we start the race?
100.
They're 100 meters. If Lisa's doing a race, and her friend's like, I'm going to be at the finish line, you be at the start line, they should be 100 meters apart. So at 0 seconds, before like the gun's gone off, how far apart should they be? So at 0 seconds,
100 meters.
100 meters. Is this 100 meters?
Nothing.
No. This one, is this 100?
Probably.
Yes. What about this one?
Just about.
Just about. No.
Just about.
And then this one. So when we say at 0 seconds they should be 100 meters apart, that's your y-axis. That's your y-intercept. They should be 100 meters apart. The question is, which of these 2 graphs is right? I'm gonna look at this. I'm gonna look at the wrong one first. Now, tell me, how long did it take her to complete that race?
Oh, that's the wrong one.
And wait.
How long did it take her to finish?
23 seconds.
23 seconds. Now this is what it says on the left. Look, this only goes to 10 seconds, right? So if you look at this graph and go, okay, if it takes her 23 seconds, then after 10 seconds, shouldn't she be about halfway done?
Yes.
On this one, after 10 seconds, she's pretty much done. She's like 1 step away. So it's not going to be this one. This one is, she's way too much, like almost done there. So then it's going to be this one, because after 10 seconds, if it takes her 23 seconds, imagine like about half of that, she's going to be about halfway done. Then as the next 10 seconds go, then she's going to be done. So it's going to be this one. She's going to start 100 meters apart from her friend, and as time goes, they're going to get closer and closer and closer together. 10 seconds, she's about halfway there, not all the way there. All right, the exact same situation. We have another one though, except for this is not Lisa, it's Sandro. I mean Sandra.
Is that a guy or
Sandro.
a girl?
I don't know. We'll see. Wait, no, it's his. It's Guy, because it says his right there.
Oh.
All right, so Sandro is training for a wheelchair race. What you're going to notice is you're going to get these problems that are the exact same, except for one thing. Circle starting line. Sandro is training for a 100-meter wheelchair race. His friend stands at the starting line and times him with a stopwatch. It takes 24 seconds to complete a practice race. Which graph models the distance between the two friends for the first 10 seconds? Now, this is kind of dumb. If I was going to go time Jacob for a race, I wouldn't stand at the starting line and be like, go Jacob, I'll stop you when you get way over there. No, you wouldn't stand at the finish line, so this is kind of dumb. I guess maybe if there's like a piece of tape he's going to break through or something.
He's getting around with them.
But instead of starting at the finish line, they start at the starting line together. So at the beginning, you got these two people standing next to each other, like one with a stopwatch and one with Jacob getting ready to run. Except for it's Sandro instead of Jacob.
And in a wheelchair.
But if you, yeah, Andy's in a wheelchair. Maybe it's Cole in a wheelchair with a code name of Sandro. Okay, so at 0 seconds, before the gun goes off, how far apart are these people? They're 100 meters. So if I'm at the starting line and Jacob's at the starting line, are we 100 meters apart?
Yeah.
No. We're 0 meters. If we're both at the same place, then we are 0 meters apart. So that's the difference. So on the first one right here, you say, okay, at 0 seconds, I should be standing right next to my friend. So it's going to be, we need to be 0. So it's not this one. It could be this one, and it could be this one. At 0 seconds, you are 0 meters away from your friend. You are at the starting line with them. Now, it takes the friend 24 seconds to complete the race. So, your graph only goes to 10 seconds. Would you imagine that after 10 seconds, like here's 100 meters up here, after 10 seconds, this person's almost done. Do you think that sounds about right? If it takes them 24 seconds, do you think at 10 seconds they're like a step away?
No. Not unless they trip the hill.
So it's not going to be this one. At this, we're looking at, see here. So after 10 seconds, you can imagine they're going to be maybe just shy of halfway there. 12 seconds would be exactly halfway. So 0 seconds we're here. At 10 seconds, you're just shy of halfway. The biggest thing to get out of these two graphs, these are the exact same problem. What's the only difference?
One's in a wheelchair.
Nope, they're both in a wheelchair. What's the difference?
Wait, they are?
One starts at the end and one starts at the beginning.
Yeah. One starts at the finish line, and one starts at the starting line. If you started at the finish line, then how far apart are you when you start?
100 meters.
100 meters. If you start at the starting line with your friend, how far apart are you? How far apart are you when you start?
Maybe 2 or 3.
Yeah, but we'll just say 0. Let's say like we're next to each other. And yeah, maybe 2 or 3, but probably like nothing. Not even a meter apart. Meter's pretty low. You're
No,
next.
Is it like 3 feet?
Yeah, it's 3 feet, 30 yards or 3 miles. I don't know.
3 miles?
I don't know. It's an arm's length. They have a meter stick. It's like that.
Well, what if you're a short person? Your arms won't be as long.
Patrick!
Okay, so that's it for modeling word problems.